So this is lesson 1 of the linear relations unit in Math 9. So we're going to be representing patterns in different ways today. First thing we're going to do though is define what a linear relation is, which is kind of the title of this unit. It's a specific type of pattern, and it's a specific type of pattern that increases or decreases at a consistent rate or constant rate. We can represent patterns like linear relations in many ways. We can use a description like words. We can use a picture or a diagram. We can use a table. We can use an equation. And we're going to be using all of these in this unit. And probably most importantly, a graph. Okay, so let's practice. Okay, so Joel begins his bike ride after school. I'm just going to highlight key things. About 3 kilometers away from his house. Every minute he travels 0.5 kilometers further from his house. So we can see here the pattern is increasing by 0.5 every minute. That's what makes it a linear pattern, because it's going up by the same amount every time. So the next minute he would be at 4.5, and then 5, and then 6.5. Okay. The pattern here, this is what's going to help us come up with the equation in a second. So we've started at 3, and then the number of times I've increased by 0.5 is dictated by how many minutes have passed. So at the beginning, it's 0 times 0.5 because I'm just at the start. And then once I've added on 1 minute, it's going to be 1 times 0.5. And then after 2 minutes, it's going to be 2 times 0.5 because I've increased by 0.5 twice, right? 1, 2. And then so on. So 3 plus 3 times 0.5. And then 3 plus 4 times 0.5. So after 5 minutes, we've done 5 increases of 0.5. Okay. Next question, is this a continuous or a discrete relationship? Important to understand that here. Essentially what this means is, like, could I go in smaller intervals? Could I look at like 0.2 minutes or 6.1 minutes? And the answer for this question is yes, because we're dealing with time, which can be divided into smaller and smaller pieces. So this one is continuous. And that's important too when we're like showing when we're representing this with a graph, we could draw a line through our points because all of the points would be part of the graph. The number of minutes can be divided into smaller pieces. It still has meaning. We'll see examples of patterns later that are not continuous, that are discrete. Write an equation that relates time to his distance from home. So we have to define some variables. Let's define time to be t. Usually you want to use a letter that kind of starts, or like that kind of has meaning. So t for time makes sense here, and d for distance. So here's our equation. Distance is going to equal, and we're going to use this pattern to come up with our equation here. So see how every single one is starting with a 3, and then it's just going to be 0.5 times the number of minutes that we have traveled. So essentially that t is the time that has passed, and that's how many increments of 0.5 we're adding on to our distance. Okay, so that's our equation. And then it says use your equation to determine how far Joel will be away from home after 30 minutes. So this time we know the time is 30 minutes, so we're going to replace it in our equation here. So we have d equals 3 plus 0.5 times t. So I'm going to replace the time with 30. 0.5 times 30 is 15. So he is 18 kilometers from home after 30 minutes. Important to have the correct units in your answer here. Okay, so that's one pattern done. We're going to do another example now, and this one is not going to be a continuous pattern. It'll be discrete, so you can see the difference. Okay, so Sarah has saved up $3,600 for her backpacking trip to Europe. So she's starting with $3,600. We can put that in the table here. She spends approximately $80 per day on her accommodations, food, transport, etc. So we're trying to kind of think about a budget and how her money is decreasing here. So after one day, for example, we're going to subtract $80, so it'd be $3,520 left. So every time a day has passed, we're going to subtract 80. So this, you can see this pattern is linear because it's decreasing at a consistent rate. Okay, so then we'll have 34.40, and then after 3 days we'll have subtracted $3 times $80, which is $33.60, and then $32.80, and then $3,200. Let's try and understand the pattern here. So start with what we began with, which is 3,600, and then every time a minute passes, so at the beginning we've had 0 minutes, so it's going to be 0 times 80, but every time a minute passes, we're going to subtract $80 off. So after 2 minutes, we'll have subtracted 2 times $80. After 3 minutes, we'll have subtracted 3 times $80, and so on. That'll help us come up with the equation later on. Okay, so again, after 1 minute, we've subtracted 80 one time. After 2 minutes, we've subtracted 80 twice. After 3 minutes, we've subtracted it 3 times, and so on. Okay, this is a discrete relationship. It doesn't really make sense to divide. It would not make sense to say like 1.2 days, because she's probably spending, like, for example, on her accommodations, she's spending that each day, not for like each minute that she's staying at the hotel. So it would not make sense to split the number of days. To split the number of days into smaller parts. It's just not practical for this example. Okay, write an equation that relates the number of days to how much money Sarah has left. So we have to come up with some variables. Let's say A is the amount. A stands for amount of money. And I like to use, you could use T for time, or I'm going to use N just for number of days. Whenever it's a number of something, I typically use N. Okay, so, and we're going to use this pattern that we developed here to create our equation. So we can see the amount is always starting with 3,600, and then it's 80 times however many days have passed, right? The N came from these numbers here. So there's our equation, and we're going to use that equation to determine how long it takes until Sarah runs out of money. So when Sarah runs out of money, that means the amount is going to be $0. So we're going to replace the A with 0 and solve for N. So we're going to solve this using opposite operations. We're going to subtract 3,600 from both sides to start. So we'll end up with negative 3,600 equals negative 80N. Right, the 3,600 cancels out there. And then we do the opposite of multiplying by negative 80. We divide by negative 80. So a nice connection here to these patterns with solving equations. So we get 45 equals N. So Sarah runs out of money in 45 days. Okay, so just a little quick recap. We saw 2 patterns here. One was continuous, where it made sense to split up the time into smaller increments, and one was discrete, where it did not make sense to split up the data into smaller increments. And then we represented our patterns in different ways. We used a table, we used an equation, and then in the next lesson we'll see some other ways that we can represent these types of patterns.